This lesson is over algebra of functions and their domain. Algebra of functions and their domain. First, we're going to start with the sum, difference, product, and quotient of functions. Now first, sum is a fancy word for what? Addition. Difference, subtraction, product, multiplication, and quotient, division. So what we're really talking about is going to be the addition, subtraction, multiplication, and division of functions. If f and g are functions and x is in the domain of each function, then each of the following holds true. F plus g of x is the same thing as f of x plus g of x. F minus g of x is the same thing as f of x minus g of x. F times g of x is the same thing as f of x times g of x. F divided by g of x is the same thing as f of x divided by g of x, as long as g of x does not equal 0. Remember, g of x in this case is the denominator, and we know the denominator can never equal 0. Example 1. Given that f of x equals x squared minus 3, g of x equals 2x plus 1, and h of x equals square root of 4 minus x. Part A asks for f plus g of 6. Now, what do we do first? We need to take the time to rewrite this. What this really means is f of 6 plus g of 6. So the first function we see is f of 6. Well, what that means is we must use the f function, which is f of x equals x squared minus 3. And in place of x, we will use the value 6. Once we've placed the value in, we now follow gems. We have no grouping, but we do have exponents. 6 squared is 6 times 6, which is 36. There's no multiplication or division, but we do see some subtraction or addition. 36 minus 3 is 33, which means we can now, in the place of f of 6, put the value of 33. Next, we look at what the operation. What are we being asked to do of these two functions? Well, we're being asked to add, so make sure you do not lose that symbol. Next, we see the function. It says g of 6, so that means we must use the g function, which was 2x plus 1. Because it says g of 6, that means in place of x, plug in a value of 6, and now we must follow gems. We have no grouping, no exponents, but we do have multiplication, and now we have addition. And so we find g of 6 actually equals 13, which means instead of writing g of 6, we can now put its true value of 13. Now our statement says 33 plus 13, which we know is 46. And we're done with part A. Part B asks us to find h times g of 0. And so the first thing we need to do is we need to rewrite this. What does this really mean? Well, the first function we see is h, so it means h of 0, times, now the second function is g, so g of 0. Now the first function is the h function, which means we must use the appropriate function, which is the square root of 4 minus x. Now every time we see x, we must plug in a 0. Now we follow gems. Under the radical we see 4 minus 0, which we know is 4. But because we have the radical, we have to see, can we find the square root of 4? And yes, the square root of 4 is 2, which means h of 0 can now be replaced with 2. Now we must keep the same operation, which in this case is multiplication. And we move to the next function. We see g of 0. So carefully go back and find what is the g function. The g function is 2x plus 1. So every time we see x, we plug in a value of 0 and follow gems. There's no grouping, no exponents, but there is multiplication. 2 times 0 is 0. And we do have addition. 0 plus 1 is 1. Which means g of 0 can now be replaced with the value of 1. And so now our statement says 2 times 1, which we know is 2. And that's our answer for part B. For part C, we are using the same functions, and again I have them listed across the top of the page. The first step we need to do is to rewrite this. This really means g of negative 1 minus f of negative 1. So we look at the first function. It is the g function, which is 2x plus 1. And now every time you see x, you plug in the value of negative 1. From here we follow gems. No grouping, no exponents, but there is multiplication. So 2 times negative 1 gives us negative 2. And now we have addition, subtraction, which gives us negative 1. So we can replace g of negative 1 with negative 1. Now the operation in this problem is subtraction, so we must keep the minus sign. And now we look at the next function, which in this case is f. Remember, f of x is actually equal to x squared minus 3. Now, every time you see x, we need to plug in the value of negative 1. And we follow gems. Notice no grouping, but we do have exponents. Negative 1 squared means negative 1 times negative 1, which gives you a positive 1. And now we see subtraction. 1 minus 3 is negative 2. So we replace the value f of negative 1 with a negative 2. So we have the statement negative 1 minus a negative 2. Well, what do you notice? Well, we have that double negative. Because we have a minus and a negative side by side, that means there is a sign change. The opposite of negative 2 is a positive 2. So our statement becomes negative 1 plus 2, which now we know is equal to 1. For part D, we are being asked to find f divided by g with the value of negative 1/2. The first thing we need to do is rewrite this. This really means f of negative 1/2 divided by g of negative 1/2. So we start with the first function, which is the f function of x squared minus 3. Now every time you see x, you plug in a value of negative 1/2. And we follow gems. We have no grouping, but we do have an exponent. Negative 1/2 squared means negative 1/2 times negative 1/2. Well, we know a negative times a negative is a positive. Now 1/2 times 1/2, because that is fractions, we must multiply top times top, bottom times bottom. And so 1 times 1 is 1, 2 times 2 is 4. So it becomes 1/4. And then we still have the -3. We have no multiplication division, but we do have addition subtraction. The problem is 1/4 is a fraction and 3 is not. So we need to make 3 into a fraction, and we do that by placing 3 over 1. So now we have two fractions, but recall, whenever you add or subtract two fractions, you must have a common denominator. Well, currently they do not have a common denominator, so we must find one. Our first denominator is 4. Our second one's a 1. So what would be our common denominator? Well, it would be 4, which means we need to multiply the fraction 3 over 1 by the fraction of 4 over 4. And so when we multiply 3 over 1 times 4 over 4, that creates an equivalent fraction of 12 over 4. Now our two fractions have the same denominator, so we can now perform subtraction. We keep the common denominator of 4 and we subtract the numerators, which give us -11 over 4. And that will take the place of the f function. Now the operation between the two functions is division. You may choose to use the slash or another form of division, another division symbol. Now we look at the second function, which is the g function, which is 2x plus 1. Now every time you see x, you plug in a -1/2. Now we have no grouping that we can do. There's no exponents, but we do have multiplication because the 2 is touching the parenthesis. The only problem is -1/2 is a fraction and 2 is not. So you may choose to write 2 as a fraction as 2 over 1 times that -1/2. Since they are multiplying, we know a positive times a negative is a negative. And because they're fractions and they're multiplying, we can reduce if anything appears in the top and in the bottom. And so 2 over 1 times -1/2 does result in a -1, and then we keep the plus 1. And we know -1 plus 1 is equal to 0. So the g function is the same thing as 0. So now we're ready to perform the operation of division. But what do you notice? You cannot divide by 0. That's not allowed. So what do we put as our final answer? We put the phrase undefined. Example E, f times g of the value 2. This is your try it problem. Let's see how you did. Hopefully you found the result to equal 5. For f, we are being asked to have g divided by h of the value 2. And our first thing is we need to rewrite this. This is the same thing as g of 2 divided by h of 2. And so we look at the first function, which is the g function, or 2x plus 1. And every time you see x, you must plug in the value of 2. By following gems, we notice there's no grouping, no exponents, but there is multiplication followed by addition. And so we find g of 2 actually equals 5. Now we keep the same operation, in this case is division. You may choose to write the slash or a different form of division. And our second function is the h function, which is the square root of 4 minus x. Now every time you see x, you plug in a value of 2. And under the radical we see 4 minus 2, which we know is equal to 2. So we still have the radical, but do we know the square root of 2? No, which means we cannot simplify and we must keep the radical. So our problem reads 5 divided by square root 2. Now that's written in horizontal form, but in vertical form it would look like 5 over the square root 2. What do you notice? Well, notice there is a radical in the denominator, and you cannot keep a radical in the denominator, so we have to rationalize, which means to remove the radical from the denominator. So we have a little bit more side work to do. We currently have 5 over square root 2. To rationalize means I must complete the set under the radical. Well, in the radical or the square root, I have a 2. Because it is a square root, it means I need a pair or a set of 2 2's. The only way to complete that is to multiply by another square root 2. But I have to be fair. What you do to the bottom, you must do to the top. And so we have 2 fractions that are multiplying. And when you multiply fractions, it is top times top and bottom times bottom. In the top, we have 5 times square root 2. In the bottom, because we have a square root 2 times a square root 2, they can be joined under the same radical. So square root of 2 times 2. Now if you can simplify a radical, you have to look at the index. Because we read this as square root, our index is a 2, which means we need 2 of the same value under the radical. Do we have 2 of the same value under the radical? Yes. Since we have a complete set, they can come out of the radical, and we can rewrite this as 5 times the square root of 2 all over 2. And that would be your final answer. Example 2. Given that h of x equals x plus 4 and g of x equals square root of x minus 1. Part A wants us to find h minus g of the value -4. Well, our first thing, just like all the others, we need to rewrite this. This means h of -4 minus g of -4. We look at the first function, which is h, and recall h is x plus 4, and every time you see x, you will replace it with the value of -4. We do gems, but there's no grouping, no exponents, no multiplication division, but there is subtraction addition. Hopefully you notice -4 plus 4 is 0. So we can now replace h of -4 with its true value of 0. Now we keep the same operation of subtraction, and the next function is the g function, which is square root of x minus 1. Now every time you see x in the g function, we plug in the value -4. So under the radical, we have -4 minus 1. We can combine -4 minus 1 by using addition subtraction, which gives us square root of -5. And so Our problem now reads 0 minus the square root of -5. But what do you notice? Problem is there is a negative under the radical. That is not possible. That cannot happen. That is not a real number. So what do we put? Well, we say that it does not exist. For part B, we have h times g of the value 3. First thing is we need to rewrite this. This really means h of 3 times g of 3. And so we look at the first function, which is the h function. As a reminder, is x plus 4. And every time you see x, we plug in a value of 3. We follow gems, but the only thing we can do is add 3 plus 4, which we know is 7. So h of 3 can now be replaced with the value of 7. We keep the same operation, which is multiplication, and we move to the next function, which is g of 3. Now the g function is the square root of x minus 1. Every time you see x, we plug in the value of 3. Well, under the radical, we see 3 minus 1, which we know gives us 2. So we've simplified under the radical, but can we simplify the radical itself? Meaning, do we know the square root of 2? And the answer is we do not. So it must remain square root 2. And so we're being asked to multiply 7 times square root 2. Can we do that? Yes. The 7 will remain on the outside of the radical. The 2 will remain under the radical. Your answer is simply 7 square root 2. Now, we've talked about adding, subtracting, multiplying, and dividing functions. Now we're going to find the domains of these operations. And so, if f and g are functions, then the domain for f plus g of x, f minus g of x, f times g of x, the domain will be the intersection of the domains. Intersection means what they have in common. Now notice, that is not all the operations. We still have another one. F divided by g of x is still going to be the intersection of the domains, but we cannot include any values that make g of x equal to 0, which means we have to be careful when a denominator is involved. And so whatever the denominating function is, it can never equal 0. Example 3. Given that f of x equals x minus 4 and g of x equals the square root x plus 2. Part A is asking us to find the domain of f. So only looking at the f function, which is x minus 4. Now, because domain is introduced, we only have to remember two key issues. Do we have a fraction? No. Do we have a radical? No. So since there is no fraction, no radical, we have nothing to be worried about. So to write our domain, we want to see what's really happening, so we look at the number line. We have no holes, no gaps, there's nothing removed, which means the entire number line would be included. So we write our domain in interval notation. The furthest left we can go is negative infinity. The furthest right we can go is positive infinity, and so that would be your domain. Next, let's look at the domain of g. Well, the g function is the square root of x plus 2. Now remember our two key issues. Do we have a fraction? No. But do we have a radical? Yes. Since we have a radical, we have to remember the approach. When you have a radical, it will be the radicand must be greater than or equal to 0, which in this case would be x plus 2 must be greater than or equal to 0. Now we must solve for x, which means we must subtract 2 on both sides, which gives us x has to be greater than or equal to negative 2. So to see what this really looks like, we draw the number line. And notice something happens at negative 2. That is a defining point. Now we must decide, what half of the number line are values that are greater than negative 2? Is that values to the left or to the right? Well, greater means bigger values, and larger values are always to the right. So we shade to the right of negative 2. Now, do we include negative 2? Yes, because it said x is greater than or equal to, that means we do include negative 2, which means you will have a bracket. And so now that we can see our domain, now we're ready to write it in interval notation, which would be negative 2 to infinity. Make sure negative 2 has a bracket. So we've looked at the individual domains of the functions. Now let's look at something else. The domain of f plus g. This is what we just learned. Now the domain of f plus g is the intersection of the two domains. So let's see what this looks like. On the number line, if we were to merge the two graphs and see what they have in common or where they begin to overlap, notice they begin to overlap at negative 2 and negative 1 and 0 and 1 and 2 and 3, and they both have arrows, which means they continue for forever that direction. So they begin to overlap at negative 2 and to the right. Now, do they both include negative 2? Yes, which means we will have a bracket on our number line at negative 2. So the two graphs overlap beginning at the value negative 2 all the way to the right, which means our interval notation would be bracket negative 2 to infinity. Now we're going to look at the domain of f minus g. Now recall, f minus g is also the intersection of the two domains, which means it's the exact same as f plus g. So the domain of subtraction of the two functions will be bracket negative 2 to infinity. The domain of f times g is what we're looking for now. Now recall, f times g is also the intersection of the two domains, which means it will also be bracket negative 2 to infinity. The last one we're going to look at is the domain of f divided by g. Now, f divided by g is really f of x divided by g of x. And we know f of x is x minus 4, and g of x is square root x plus 2. Now this is a fraction, and because it's a fraction, we must be concerned with what part? The denominator. We know the denominator cannot equal 0. Well, in this case, our denominator is square root of x plus 2. which means we cannot let this radical equal 0. So we solve for x, and to do that we would subtract 2 on both sides, and we find x cannot equal -2. So on the number line, that means at -2 I cannot include it, so I must put an open circle. However, I can include all the other values they have in common, which would be all the values to the right of -2. And so, writing our interval notation, we start shading at -2, but because we do not include it, we must use a parenthesis, continue to the right for forever, which is infinity. Example 3. Given that f of x equals x minus 4 and g of x equals square root x plus 2, find f plus g of x. Now in this case they are asking us to add these two functions, so we do need to take the time to rewrite this. This really means f of x plus g of x. But what do you notice is different? Well, this time they did not give us a value to plug in. Good news is that doesn't change anything. We look at the first function, which is f of x, and f of x is the same thing as x minus 4. So we keep it as x minus 4. Now we keep the same operation, which in this case is addition, and we look at the second function, which is g of x. Again, we do not have a value to plug into the function, so we must keep it as g of x, or square root of x plus 2. So our expression is now x minus 4 plus the square root of x plus 2. By following gems, we notice we cannot do anything inside grouping. We have no exponents. There's nothing to distribute in front of either of the parentheses, and we have no like terms, which means your answer will remain x minus 4 plus square root of x plus 2. For C, it says find f times f of x. So again, we will rewrite this. We rewrite it as f of x times f of x. Again, they did not give us any values to plug into the functions, so we know the f function is the same thing as x minus 4. We keep the same operation, which is multiplication, and then the second function is f of x, which again is represented by x minus 4. So since we have x minus 4 times x minus 4, we follow gems. We cannot do anything inside the grouping. We have no exponents, but we do have multiplication. We need to distribute the values. So x times x is x squared. X times -4 is -4x. Now we distribute -4. -4 times x is -4x. -4 times -4 is +16. We now have 4 terms, and we try to simplify if possible. Notice your middle terms can combine, and now you have x squared minus 8x plus 16. Problem D, find f divided by g of x. Just like all the others, we need to rewrite this. This really means f of x divided by g of x. We look at the first function, which is f of x. But notice they did not give us a value, so we simply replace f of x with the function x minus 4. We keep the same operation, which is division, and now we look at the second function, which is g of x. Again, they did not give us a value to plug into the function, so it will remain square root of x plus 2. Now this, because it says division is written horizontally, I want to write it vertically, which means this is the same thing as x minus 4 all over the square root of x plus 2. Notice we do have a radical in the denominator, but because there is a variable inside the radical, we do not need to rationalize. Example 4. Given that f of x equals 4 all over x plus 1 and g of x equals 1 all over 6 minus x. Well, first we're being asked to find the domain of f. Well, only looking at the f function, which is 4 over x plus 1, because it's domain, we look for our two key issues. Do we have a fraction? Yes, which means our denominator cannot equal 0. Well, in this case, our denominator is x plus 1. So x plus 1 cannot equal 0, and to solve for x, we subtract 1 on both sides, giving us x cannot equal negative 1. So visually, on the number line, we find negative 1, and we are going to have a whole. That's the one number we cannot use. However, I can shade to the left of negative 1, and I can shade to the right of negative 1. And so now that I see my number line shaded, I'm now ready for my interval notation, which is negative infinity to negative 1, union negative 1 to infinity. Next, we're going to look at the domain of g, which means only looking at the g function, which is 1 all over 6 minus x. We ask ourselves, do we have a fraction? Yes, we do. Now, because we have a fraction, that means the denominator cannot equal 0. In this case, our denominator is 6 minus x. Now, to solve for x, you may end up subtracting 6 from both sides. When you do that, that leaves you with not x, but negative x cannot equal negative 6. To isolate x, we need to divide the left side and the right side by negative 1, and we find x cannot equal 6. So on the number line, we know that at the value of 6, we will have a whole, or an open circle. But all the other numbers we can use, which means I can shade to the left of 6 and shade to the right of 6. And so now that we can see our number line, we can now confidently write our interval notation as negative infinity to 6, union 6 to infinity. Now we're being asked to find the domain of f divided by g. Now f divided by g, this is an operation which is always going to be the intersection of the two domains as long as the denominator will never equal 0. Well, f of x over g of x means the denominator, which in this case is the g function, cannot equal 0. Well, our g function is represented by 1 over 6 minus x. Notice we have a fraction. You can get rid of the fraction by multiplying the left side of the equation and the right side of the equation by the common denominator, which in this case is 6 minus x. On the left side, the 6 minus x will reduce to 1, and on the right side, 0 times anything is always 0. Now notice our statement, 1 cannot equal 0. Where did our variable go? Because our variable disappeared, it means we are not concerned about the denominator ever equaling 0. Because it's a false statement, because the variable disappeared, we don't have to worry about that technicality. So it just means we look at the intersection of the two number lines. So notice the first number line, we had a hole at what value? -1, which means we're also going to have a hole on our domain intersection. The second graph has a hole at what value? 6, which means our graph will also have a hole at 6. But all the other values work for the first number line and the second number line. So that means on our new number line, we can shade to the left of -1, we can shade between -1 and 6, and we can shade to the right of 6. Which means now we're ready for the interval notation, which would be -infinity to -1, union, -1 to 6, union, 6 to infinity,